Welcome to Stitchless Circle Optics in Focus. I'm Jennifer Sertle, Vice President of Marketing at Circle Optics and your host. Our hardware may be groundbreaking, but it's our software that truly unlocks its full potential, transforming raw data into real-time situational intelligence for a safer, smarter, and more immersive world. In this series, you'll meet the engineers, developers, and problem solvers really building innovative solutions that make our technology really one of a kind and groundbreaking. We'll explore not just what they've created, but really why it matters for mission-critical operations, immersive training, and a safer, more connected future. Starting the software segment, we're going to be talking to Pete Stubler and Steve Fowler, that are two people that are really kind of designing the structure of the software team and really kind of shaping the roadmap, how we're moving forward. So welcome to the program. And I'd love you to begin sharing each, what is your name, role, and what drew you to imaging system design? That'd be great.
Sure.
Pete, we'll start with you.
My name is Pete Stubler. I am the Director of Image Science. What drew me to imaging, I started taking pictures. I found a family camera when I was in middle school. I bought my first SLR going into my junior year in high school so I could be in the yearbook staff. My first job was working in Kodak research labs where I spent several decades in Kodak research, and every step of the way in different capacities, I've been working on imaging systems.
Yep. So I'm Steve Feller. I'm a senior software engineer, and I kind of took the opposite end. Pete and I approached a lot of these problems from completely different directions. I started at the driver's level, interested in like low-level computer hardware and software, which is where cameras live, and then working backward from that. So I'm more interested in how pixels get collected, and then providing it to people like Pete to do the processing on. It started when I was in undergraduate. The university I worked for had gotten a new camera without any user interface to it, and they needed an undergraduate project to make that interface. So I made the interface, got interested in cameras, and I got pulled up. In the master's, I did some work in kind of imaging different products for agriculture, and then that led to camera arrays, and then now I'm at Circle Optics building big cameras for Pete.
That's great.
Or helping Pete build them.
So I'll go ahead and start with you, Steve. What problems are we trying to solve that no one else is?
Well, I think what we do with the cameras at Circle Optics core technology is low parallax imaging systems, which means we can put multiple cameras together and they appear more like a single camera than other systems that can do that. And that allows us to get both high resolution, highly accurate images, which is kind of Pete's domain, and I'm sure he'll tell you a lot about that, but allows us to do it in a smaller package. And so we can be more efficient about the pixels we collect, we can be more efficient about how we process them, and yet we can generate unbelievably high quality results. So
it turns out that this whole thing about low parallax, that is a problem that our founder actually worked on. He had taken a class where one of the assignments was to create a low parallax. This is how to put two cameras together in such a way that objects that are in the foreground, objects that are background, don't conflict with each other between the two cameras. And he was told at the time that there was a solution that could be obtained for two cameras, but not from an arbitrary number of cameras. And this is a statement that really, really bugged him. And he kept on working on that in his spare time until he actually solved that problem that was thought to have no solution. And so he founded the company based on this idea of creating arrays of cameras that share this property, that they can be stitched together with traditional stitching. It has to be done algorithmically. It has to be done by a computer. And every step along the way, a computer has to make a decision, or the algorithm has to make a decision as to how to solve these problems where you have things in the foreground and the background that don't quite agree between the cameras. Without that problem, the stitching together becomes a much easier solution, and we can actually create these very large, very high resolution panoramics, that instead of calling it stitching, we actually have adopted the term quilting, because the only real actions happen right on the edges.
Yeah. And we have had an earlier program of Stitchless. We had the founder, Zach Niazi, and COO Ian Gauger talk a little bit more about that. So I'll be able to embed that. And what's interesting is that it's easier for us to see the mechanical and the optical system, but we don't really understand the ghost inside, the software inside. Can you speak a little bit about like how do you make it work? You only have 2 minutes. How do you make it work?
Well, honestly, in a system like this, the biggest thing is actually gathering the data, assembling it, and moving it around. The actual image science, my part of the job is actually in understanding, and primarily it's in calibrating, color balancing, providing the ability to make it look really good. But the hardest problem is actually what Steve's dealing with, and that is moving the data around, because it is so high resolution. It is so volume of data concentrated that becomes one of the primary design constraints for our camera systems. Go.
Yeah, well,
what a great setup. I love it.
I think this is a great case where you know your domain, because I think what Pete does is much harder than what I do. And so we will both claim that the other one. But I think Pete's right. The challenge is balancing all these things, right? Mm-hmm. It's not just imaging. It's not just data management. But given what you want to do, given the constraints of the environment you're going to work in, how do you optimize a system to accomplish those goals? And I will say one of our goals across the board at the software team is like anything. You want it so that the people on the outside, it looks easy, no matter how hard it is internally. And I think that is kind of what we do, is we focus on a lot of complexity so that when you see our images, you don't think that it's an array of multiple cameras. You don't have to worry about all the details that go into managing that it's just kind of a clean, nice user interface, easy to understand data coming out. So that's how I would answer that question.
Okay, I appreciate that. And, it's hard. A lot of times we're moving from being a prototype company to a product company, and we haven't really had very good specs come down the pipeline to design with. What are some ways that we in the business development side can do a better job helping support what you may need to do the little magic that you're doing?
Moving from prototypes to production is hard. In my career, I have actually had the good fortune of taking probably 7 different research projects that I was in the seminal team and bringing them all the way to a production product. And it is striking to me how many things you don't anticipate that come up in that process of moving from a concept in the research labs to a product out in the public. And as to the direct answer to your question, be conscious of it.
Yeah.
That's it.
Well, I'm just wondering if I think of the seven experiences that you had before. I love that number 7's a divine number, but that's kind of cool. But if you thought about 3, another divine number, are there any 3 things that actually was similar across all 3 transitions that we can be mindful now, or was each transition its own? Was there any overlap in learnings from the 7? And again, this was an unrehearsed question.
Yeah, it was.
But it's a good one.
I'm just fascinated by what we can learn.
Hard.
Yeah. Is there anything that we can learn from a design perspective that will help us design for complexity better as we make this transition? And then I'm going to move to you and your experience, Steve, in just a minute.
I'm going to make a quick statement and then can pass this over to Steve.
Lazy.
So one of the things that I have throughout my entire career, because I have worked in several different capacities. My first projects, I was actually a hardware engineer. My second and third projects, I was embedded software. And then the remainder of them were true imaging science algorithm design. Each of those domains provided me with an opportunity to learn more. And each challenge can inform you in ways down the line that you don't anticipate. There's every challenge you're presented with provides new learning opportunities, and I literally cleave onto that concept that everything that I do is an opportunity to learn more.
Yeah, I love that. And so just as a soundbite, like what I'm hearing is that it'll be more complex than you think. And you need to pay attention to all of the interactions and how they, like a complex system, everything changes everything. And so just to pay attention to the nuance and track the nuance, which is really why we're excited to have Steve on the team, because he's actually also been through the commercialization process with camera systems as well. So answering that same question, having had success in the past with this complexity, what are some things we can learn as we move forward?
I mean, everything's a matter of trade-offs and understanding where the complexity is at the time you are in the process. And I think the key word there is process. And so my advice for startups, both, this is what I learned in previous experience building extremely high resolution cameras, is you start at R&D where it's really a technical problem. But to get beyond that, you really need to look at the processes so you can come up where are the decision points when when do you move to the next level? When do you go from R&D to product? How do you decide when to grow your team? How do you decide when your resources shift from pure R&D to more of a stability and reliability and customer-facing needs versus, support and long-term viability? And so I think that's one of the key things is understanding what processes need to be in place. And then going back to your early question, what you can do to help us is give us it doesn't have to be a quantitative, these are the specs you need to hit, but a qualitative understanding of what the customer needs and expectations are. It's much different if your customer's in security, where they need 30 days of stories and 3 nines of reliability, versus someone who is flying on a drone for 20 minutes that just wants to get a good picture of their house. And so the range of the scope of what you do needs to be defined kind of qualitatively first, and then we can apply the processes that I referred to earlier to help refine what our piece of that is and how to approach those problems.
That's great. You've been listening to Pete Stubler and Steve Fowler, really designing the roadmap for our software team. Thank you for joining us.